This simulation is going to help us to understand the difference between transverse waves and longitudinal waves. So we're going to start with transverse waves. So here I'm going to disturb the system like this, and when I let it go, you see that the charge, these points here, they vibrate up and down, and they vibrate perpendicular to the length of the string. So whenever you have a vibration that vibrates perpendicular to the length of, for example, here the string, then this is going to be called a transverse wave. And for light, it's similar. The light vibrates up and down as it moves side to side. So here, the vibration is perpendicular to the direction of motion. So we're going to go, this is called a transverse wave. Now let's go ahead and look at the other case. So here we're going to make them vibrate. So let's go ahead and look at this case here. Let's stop it first. So if you notice here, now picture these to be air molecules, and you're creating sound with your voice. So what's happening is that in some places the air molecules are compressed next to each other, and in other places the air molecules are more spread out, so they're rarefied. And so let's go ahead and run this to see how this looks like. So you notice here that these charges are, these air molecules are vibrating back and forth or side to side, but also the wave is traveling side to side as well. So the vibration here is going to be along the length of this string here. So these are called longitudinal waves. So transverse waves, they vibrate perpendicular to the direction of motion. And longitudinal waves, they travel in, they vibrate in the direction along the direction of motion. And so these longitudinal waves, they can be represented as sound waves. So this is how sound waves travel from your voice to somebody's ears. And light vibrates in this direction, or vibrates like this. It travels like this. So it sends electric fields that vibrate up and down, and those electric fields travel into your eye from side left to right.